Yes. Yeah, good evening all. So myself, I'm Vijay. Like I hold 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Okay. Fine. So the session goes for 2 hours, next to 2 hours, right? Yes, session goes for next 2 hours. Fine. So what is big data? Why Hadoop? Drawbacks with the current databases, Hadoop advantages, Hadoop job market. So after this, I'll be discussing how exactly the storage and processing is going to happen within this Hadoop, right? So if we talk about this big data, right, huge volumes of data, currently the data storage units like KBs of data, MBs of data, or GBs of data. Yes, GBs, even should have seen KBs or MBs or GBs, but there are TBs, petabytes, exabytes, zettabytes, etabytes, and zettabytes of data, right? So from TB onwards, we say like huge data or big data. Currently, if we say huge volumes of data is getting generated, right? So currently we have got some databases. Currently we have got databases, right? For storing this data. Yes. Currently we have got a databases for storing this data like Oracle, MySQL, SQL Server, DB2. And we have got some specialized databases, right? Specialized databases for data warehouse purposes, right? Yes. Fine. Like Teradata, Netezza, Vertica, all these are the databases used for data warehouse purposes, right? For OLAP operations. So, but these databases and specialized databases, they can handle data up to some extent only, like GBs or even TBs, right? But beyond that, they cannot support the data. Okay. Today, we see how this data is getting generated, how this data. So we see like in every application generating huge data today. Today, most of the projects are migrating to this Hadoop and Spark environment because huge data is getting generated by every applications. Like talk about this Facebook, what is the data generated by Facebook, right? Huge data, and even for Google, right? Google generating huge data, and YouTube videos, right? YouTube also has got huge data is getting generated, right? Yes, we need to have some proper storage systems for storing it, and also apart from this, like bank transactions, telecom transactions, e-commerce sites like Flipkart, Amazon, right? Huge transactions are happening. Huge data is getting generated everywhere, right? We say that as huge data, big data, right? Not in petabytes. Should have seen, about TBs, but beyond that, we have got petabytes of data is getting generated now. For handling the petabytes of data, for storing the petabytes and processing the petabytes of data, we have got frameworks like Hadoop. So if we see from the last, 50 years, right? Especially from the last 10 to 15 years only, huge data is getting generated. Means if you see in GBs or in TBs, but before that, right, in 1990s or 2000, right, you can see data in KBs or in MBs only. KBs or MBs. That's why we got like floppy disk CDs in MBs where they used to store data in MBs. But now we have reached TBs petabytes now. TBs petabytes, right? 1024 TBs forms 1 petabyte. So yes. So because of how this huge data is getting generated because of this technology, because usage of technology, because of usage of smartphones, because of usage of internets, huge data is getting generated everywhere, right? When we see data in structured format, in unstructured format, in semi-structured format, but the biggest challenge is to handle data in unstructured data, unstructured format or semi-structured format. Current databases can handle only structured data. Current databases can handle only structured data. They cannot handle unstructured or semi-structured data. So as a solution to all this, right, we have got a framework like Hadoop. Hadoop, any technology, if you take, either it is meant for storage or processing. If you take these databases, Oracle, MySQL, all this, they are used for storage, right? And if you take about the technologies like C or C++, Java, .NET, all they are meant for processing. Means you see either they are meant for storage or for processing. They are meant either for storage or processing. They are meant either for storage or processing. But Hadoop is meant for both storing and processing. For storing, we go for HDFS, and for processing, we have got MapReduce or Spark. Okay. Storage will be HDFS and processing will be MapReduce or Spark. So Hadoop is meant for both storage and processing. For storage, it doesn't use any database. It doesn't use any database for storing. Instead, it is using a special kind of file system called HDFS, Hadoop Distributed File System. And for processing, it is using execution model called MapReduce or Spark. So when you have got, when Hadoop is able to perform both storage and processing, when it is going to store and process, what is the necessity of the current these databases then? And what is the necessity of the current databases? Okay, means you need to clearly understand Hadoop is not for online processing. Hadoop is meant for batch applications. Hadoop is meant for batch applications. Hadoop is not for online applications. Hadoop is not for online applications. Online applications means for a single transaction or one transactions, two transactions. For one transactions, two transactions, right? Yes. No need of, for one transactions, two transactions, no need of Hadoop. For millions and trillions of transactions, go for this, right? Yes. Okay. There are two types of applications. There are two types of applications, right? Online applications and batch applications. Online applications, user interactive applications, right? Here user gives the input, making a online payment, right? Booking a movie ticket. Here user gives the input. User interactive applications where user gives the input. Here booking a movie ticket or making a online payment, right? All these are right. Yes. And batch applications, user non-interactive applications. Here user is no way required. User is no way required. Everything happens in the background, right? For example, railway ticketing PNR status. Generate, okay, PNR, for example, your waiting state is currently 200. After 2 hours, it is 150. Tomorrow morning, it is 100. Tomorrow evening, you got confirmed, right? So everything happens. Your user has nothing to do. User has nothing to do, right? User involvement. Here, user involvement is not required here. So everything happens in the background. Generating credit card statements for millions of customers. Generating credit card statements for millions of customers. Generating credit card statements for millions of customers. Okay. Okay. So these are, okay, Hadoop is for batch applications, not for online applications. But Hadoop, if it is integrated with NoSQL database, right? If integrated with NoSQL databases, then we can perform both. It can perform both batch applications and online applications. Yes. Yes. Drawbacks, what are the why drawbacks with the current databases? Drawbacks with the current databases. Why Hadoop doesn't use databases for storing its data? What are the drawbacks with the current databases? Yes. First thing is limited storage. In most of the databases, limited storage. Yes. Okay. Most of the databases, right? The drawbacks with the databases, limited storage, GBs or in database. No parallel processing. No parallel processing in most of the databases, right? As volume, okay. So most of the databases, limited storage in GBs or in TBs, and no parallel processing in most of the databases. As volume increases, speed decreases in most of the databases. If volume increases, as volume increases, speed decreases. If you see how come if volume increases, speed decreases means total amount from sales one, total amount from sales two, total amount from sales three. So if you are selecting the total amount from sales one, total amount from sales two, total amount from sales three, right? Okay. So if you see first, this is one table, sales one has got 10 records. Sales two has got 1 lakh records. Sales three has got 1 crore. Okay, 10 records, 1 lakh records, 1 crore records. Which query is going to execute faster among these three? Total amount of 10 records, total amount of 1 lakh, or total amount of 1 crore. The first query execute faster as compared with other things, right? So query to query, as volume increasing, speed decreases in the databases. Complexity increases, speed decreases. If the complexity increases, speed decreases. Total amount from sales one, average amount from sales one, standard deviation of amount from sales one. Total amount from sales one, average amount from sales one, standard deviation of amount from sales one. So here, average amount is a two-step process. First sum has to be calculated, next average has to be calculated. So it's a two-step process as compared with the first one. Second query is going to take more time. And standard deviation of amount, it takes a lot of internal processing is required. Lot of internal processing is required compared to the first query, second query. The third query is going to take more time. Databases can handle only, the next one thing is databases can handle only structured data. They cannot handle unstructured or semi-structured data. For example, right? If you want to take reviews for a particular movie, yes. This is a table, reviews table, right? Reviews table. You got a table like structured way. User, and review. User one, user two, n number of users giving the request, right? N numbers of users giving the request. Now, yes. Now they are giving the review. User one saying the movie is good, saying 0. They're saying in the form of ones and zeros. They're saying form of zeros and ones. Fine. Can you write an SQL query? Can you write an SQL query to count the number of zeros and ones here? Yes. Can you count the number of ones and zeros? Can you write an SQL query to count the number of zeros and ones here? So count aggregation, right? Select select review wise count from reviews table, group by review. Reviews, select review wise count from reviews, group by review. Review wise count I want from reviews table, group by review. The output you can check, right? The output. reviews like ones and zeros, right? How many people saying the movie is good? 90 people saying the movie good, 10 people saying the movie is bad. Yes. So 90 people saying it's good, 10 people saying the movie is bad. So yes, but if the reviews are given in their own text format, like first person saying movie is good, second person saying movie is not good. So in this way, they're giving them in this one form. Okay, movie is good, movie is not good, right? In this way. Can you write an SQL query to count the number of goods and not goods? We cannot handle this kind of data. Previously, it was in structured format. Okay. But even if you count by using the keyword count, right? It gives wrong computation because even not good has got good within it, right? So we cannot count the number of goods and not goods. Okay, so databases can handle only structured data. They cannot handle unstructured or semi-structured, but Hadoop can handle all varieties of data like structured, unstructured, and semi-structured. See, Hadoop doesn't follow client-server architecture. Hadoop doesn't follow client-server architecture. Hadoop follows master-slave architecture. Hadoop doesn't follow client-server architecture. It follows master-slave architecture. Single master, multiple slaves. Single master and multiple slaves. For example, master node, these are the slave nodes. Master and slave, master and slave. S1, S2, okay. Single master and multiple slaves. Master node or we say like a name node. That is the process, right? Slave nodes are data nodes. Why the name data nodes? Because data is stored within the slaves, data is processed by the slaves. In Hadoop, data is stored in the form of files, f1.txt. In databases, data is stored in the form of tables, but in Hadoop, data is stored in the form of files. Think that each slave capacity 1 TB, 1 TB, 1 TB, right? Yes. But if this file size is 2 TB, if the file size is 2 TB, this 2 TB file cannot fit into any of this slave, right? It cannot fit into any of this slave. Yes. Yes. Means in Hadoop, data is distributed, right? Yes. This data is divided into smaller parts. Each part is going to be stored across multiple systems and are processed parallelly. Two advantages you can see here, right? Two advantages you can see. Distributed storage and parallel processing. So here master node assigns the task to the slave, T1 task, T2 task, T3 task. T1 task to S1, T2 to S2, T3 to S3. So who assigns the task? Master. Who executes the task? Slaves. And the tasks will be equally assigned, right, to the slaves. Load balancing, we say. And if any slave goes down, then the task of it will be assigned to any of the other slaves. Right? Yes. Okay. This if the task of it will be assigned to any of the other slaves. This process we call it as fault tolerance mechanism. This process we call it as fault tolerance mechanism. Yes. Master node responsibilities, task assignment, load balancing, fault tolerance, and health monitoring, right? So before assigning task to the slave, first master node will have the entire information about the slave and its health status, right? Yes. Slave node responsibilities, only two responsibilities: to store the data and to process the data. To store the data and to process the data, right? Two responsibilities. Hadoop advantages, right? Hadoop advantages. Now coming to the discussion what we had, right? So later I discuss in brief about that architecture, right? Hadoop architecture, storage architecture and processing architecture, right? Hadoop advantages. First thing is unlimited data storage is possible, right? Because of a feature, right? Horizontally unlimited scalability, right? Unlimited storage, horizontally unlimited scalability, very high speed processing because of parallel processing. So in Hadoop, unlimited data storage because of this feature, horizontally unlimited scalability. Horizontally unlimited scalability means, so as we said, like Hadoop has got master slave architecture, single master, multiple slaves. Means today, if you are running a business, a very small business with less number of systems, right? Tomorrow, if your business has increased, if your data is increased, if customers are increased, you cannot go with the same number of systems, right? Yes, if data increased by 100 times, customers increased by 1,000 times, you cannot go with the same number of slaves. Horizontally, we will keep on increasing the systems. Only one master, multiple systems, multiple slaves. Okay. Very high speed processing because of parallel processing. Because of parallel processing. Parallel processing and non-parallel processing. What is the difference you observe? So if you take parallel processing and non-parallel processing, right? Yes. Non-parallel and parallel. Assume that if I take a labor example, one person preparing one item taking 1 minute. The same one person preparing 10 items taking 10 minutes. The same one person preparing 100 items taking 100 minutes. But in the case of parallel processing, one item taking 1 minute only, 10 items also taking 1 minute, 100 items also taking 1 minute. Means here 10 people preparing 10 items take 1 minute. 100 people preparing 100 items taking 1 minute. Okay. The same way in our, so here systems we say, systems, multiple systems. There we say 10 people, here 10 systems or 20 systems, right? Running parallelly. Okay. Very high speed processing because of parallel processing. Can handle all varieties of data. Can handle all varieties of data. Open source, no licensing required, right? See, most of the Hadoop products are from Apache Megastruct, from where we'll be downloading and we'll be installing. Commodity hardware, no need of highly configured systems. Hadoop can run on any system, right? Commodity hardware. So very high speed processing and unlimited data storage. We have got some. Yahoo has taken a table of 100 TB. See, Yahoo has taken a table of 100 TB consisting of 1024 columns. Task, sorting based on 16 columns. Okay, what is the task? Sorting based on 16 columns. What is the time taken by the different databases, right? Yes, Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours. See, this Oracle has taken 3.5, MySQL has taken 6 days to process this 100 TB data. Teradata has just taken 4.5 hours. Vertica has just taken 3 hours, right? Yes. Hadoop has taken 3.2 minutes. The latest version of Hadoop has taken just 2.1. Means, yes. See, this 3.5 days are hours, right? But Hadoop has taken in minutes. And this processing point of view, Hadoop has proven in the market very high speed as compared with any other thing. And storage point of view, right? Yes. Check this. Why databases like Oracle won't support unlimited storage? Why databases like Oracle won't support unlimited storage means? Even for databases, we have got some limit on the, even in real time, this databases like Oracle can go with multiple systems. Databases and limit on number of slaves. Oracle, maximum you can go with 256. MySQL, it can go with 54, right? MySQL Express can go with 256. DB2 with 256. SQL Server also can go with 256, right? Teradata, it's a data warehouse. Kind of data, it's a specialized database used for data warehouse purpose. It also can go with 512 nodes. And Netija can go with 512, Vertica with 512. But in latest, currently that Teradata going with 1024 nodes, Netija with 1024 nodes. But there is no limit on the number of nodes that Hadoop can have. Unlimited scalability. There is no limit on the number of nodes that Hadoop can have. Unlimited scalability, that is unlimited number of nodes can be added. Okay. So yes, Yahoo when first time implemented Hadoop went with 4,000 nodes. Currently it's going with 12,000 nodes, right? Facebook when first time implemented Hadoop went with 12,000 nodes. Currently it is going with 42,000 nodes, right? Yes. Facebook currently going with 42,000 nodes. Means not like 256 or 512, it is going with thousands, 4,000, 12,000, 42,000 nodes, right? Yes. Yes. So there is no limit on the number of slaves that Hadoop can have, right? Unlimited. Okay. So, okay, that's fine. Hadoop ecosystem components, what I'm going to discuss as part of this, right? HDFS that is meant for storage, a MapReduce for processing, Hive also for processing. We use a language called HQL, which is similar to SQL. Scoop for import or export operations, right? For import or export. NoSQL database like schemaless behavior or random access. Scoop for importing data from different databases to Hadoop and export the data from Hadoop to databases. NoSQL, schemaless behavior, and random access. HBase is one of the NoSQL database. Yarn, right? Yes, yet another resource negotiator. That and two streaming components I'm going to discuss like Flume and Kafka, and Zookeeper controls and coordinates all these other components, and PySpark in brief, right? Like Spark, PySpark core programming like PySpark SQL and PySpark streaming, right? This what will be. If you see this course content, right? You just observe this course content like Hadoop, HDFS in brief, MapReduce in brief, Spook component, Yarn, NoSQL, HBase, Hive. Hive in brief, Hive is a kind of data warehouse kind of environment in Hadoop framework. We will create tables and working with unstructured XML, JSON, URL, creating locals, creating UDF, UDAF, UDTFs, partitioning, bucketing, indexing, all right. And coming to PySpark introduction, PySpark RTD computation, persistence options, PySpark core or computations, groupings and aggregations, various actions and transformations one by one with various working examples, PySpark SQL data frame one by one, right? PySpark SQL functions and various built-in functions of PySpark one by one in brief, PySpark external sources, deployment modes, PySpark applications creation, streaming integration with Kafka, right? Yes. And machine learning libraries integration with Kafka and streaming concepts will be discussed. So just I'll also just give some introduction to this PySpark. Yes. So next, fine. Observe this. So observe this. This is what we have discussed. So just I'll give that introduction to this PySpark and also how exactly the data storage and processing is happening in Hadoop environment, right? How exactly the data storage and processing is happening, right? So just as it's a weekend batch, right? We'll be spending more time, I said. So we'll have a break for 20 minutes and we'll come back and we'll discuss about this small introduction to this PySpark, followed by data storage and data processing. Just I'll be starting with how exactly the data storage and processing is happening within this Hadoop, right? Yes. So 1 second. So just we'll take a 20 minutes of break. So just I'll keep the meeting in mute. You can join the session, right? Yes. Session starts at 5:15, right? We'll just join the session 5:15. Same. You can So just I'll keep the meeting in mute. We'll start at 5:15, just 20 minutes of break. We'll come back and discuss, right? Yes. Fine. Okay, before that, have you got any queries, anyone? Right. Before this, if you got
I have a question.
yes.
Why is there a limit on the nodes for databases?
So
I can't
database,
feel.
yes, in data, there is a limit on the database. Maximum it can support up to 256 nodes only. Beyond that, they cannot support. And for Hadoop, unlimited scalability, there is no limit. We can keep on increasing, right? Fine.
Hi, sir.
Yes.
Sir, will there any reduction in the job of the database developer due to big data? Hadoop?
Hmm?
Will there any reduction in the job of the database developer, like Oracle database developer, MySQL database developer?
Okay, yes, sir. Where you are going to get the data from? Where you are going to get the data from? From databases only, right? Hadoop is going to pull the data from different databases only. So you need to have the knowledge of database, right?
Yes.
So you are going to pull the data from different databases. So I got some 10 branches. From 10 branches, you are going to pull the data to HDFS, where the data can be stored at one place, huge data. And after that, I'll apply some business logic. And I'll process it as per my business logic. Again, I can export the data to databases, right? Importing and exporting, yes.
And at the last, will you give the project so
Yes.
that we can put
Yes,
in our resume?
Yes, definitely. I'll be discussing one day flow of the entire flow. I'll be discussing, right? Yes. Fine. Okay. Still any other queries, right? So that is the course content. Fine. So just take 20 minutes of break. We'll again discuss more on this. Session starts at 5:20. Just 20 minutes of break. 5:20. You can we'll be back. So still, if you have got any queries, you can ask me up after the session. Fine. Okay. Yeah, welcome. Yes. So how exactly the data storage and data processing is happening within this Hadoop environment, right? Yes. Data storage and data processing. How this data storage and data processing is happening within this Hadoop. Just try to understand this. Yes, in Hadoop, data is stored in the form of files. Data is stored in the form of files. Each file is again subdivided. Each file is again subdivided into blocks. Means a file is divided into blocks. Block 1, block 2, block 3, in this way, multiple blocks. Blocks are distributed across see, each default block size is 128 MB. In the old versions, the block size was 64 MB. So in older versions, default block size was 64 MB, right? What is the block size? 128 MB, and in the old versions, it was 64 MB. We can also set our own block size. We can also set our own block size, right? Yes. Default block size. F1.txt, the size is 200 MB. Yes. So assume default block size is 64 MB. So this file size is 200. Default block size assume 64 MB. Means this 200 MB file will divide it into 64 MB blocks. We divide into 64 into how many 64 blocks? So how many blocks the file is divided, right? File size by, yes, file size by default block size. File size is 200, default block size 64. So what you got? 4 blocks. 200 by 60. That is what? 4 blocks. Okay. 200 by 64. Totally how many blocks? 4 blocks. Four blocks. B1, B2, B3, and B4. Ajay Patekar, right? This is the session 1, right? First session.
First session, right?
Yes.
Okay.
So it started 1 hour ago.
But I was not having that link. I just joined.
So okay, you can go to the video, right?
Okay. It was demo or how was that?
Demo only.
Okay.
Yes. So it is 200 by 64. In Hadoop, always data is stored in the form of files. The file will be divided into multiple parts. Into how many parts means 64, 64, 64 MB blocks or 128 MB blocks. If you give 64, 128, okay. Otherwise, if by default, if you won't give anything, it will be taking 128. Or we can set to 64. Or you can also set to your own size, right? Like 50 or 100. So here 200 MB file divided into 64 MB blocks. How many blocks? B1, B2, B3, B4. Because 4 blocks, right? B1 size 64 MB, B2 size 64 MB, B3 size 64, B4 size 8 MB. B4 size is 8 MB, right? Totally 56 MB, right? So here 56 MB is free in the B4. Only 8 MB is stored. 56 MB free in this. Okay. Now, file1.txt is a banking data. Assume the data what is stored is banking data. f2.txt, whatever data stored in this file 2 is telecom data. Its size is 192 MB. Into how many blocks this file is divided means 192 by 64. 192 by 64. 3 blocks. It's divided into 3 blocks. B5, B6, and B7. B5, B6, and B7, right? So 3 blocks, 64, 64, 64 means 192 by equal into 64, 64, 60. Here the query is 56 MB is free in this. Why this B5 data is not stored in B4? Why B5 data is not stored in B4? If B5 data stored in B4, assume if you are retrieving f1.txt, if you are retrieving this f1.txt, B1 plus B2 plus B3 plus B4, B1, B2, B3, and B4. Retrieving file 1, nothing but retrieving all this. But if B5 data is stored in B4, if B5 data is stored in B4, yes, Okay. 64, B2 64, B3 64, B4 8 plus 56. 8 plus 56. Totally 256. Totally 256. But actual file size is 200 MB only, right? So wrong computation. You see what? Wrong computation here, right? Yes. Yes. So every file should have its own block size. Even though if the data is free, also not a problem. Every file should have its own blocks. Yes. Design principles with respect to HDFS blocks. Design principles with respect to HDFS blocks. Every file will have dedicated number of blocks. Every file will have dedicated number of blocks. In a single block, no two files data to be stored. No two files data to be stored. Every block will have equal volume except the last block. Every block will have equal volume except the last block, means see here, all will have equal volumes except the last block, right? Yes. Okay, next. Just observe these things, right? Yes. How exactly the data storage and data processing is going to happen. How exactly the data storage and processing is going to happen. So here, try to understand this. Case 1, I'm going to discuss 3 cases. Case 1, if the number of blocks, if it is equal to number of slave systems, 3 blocks equal to 3 slaves. Three blocks, 3 slaves. f1.txt, assume the file size 192 MB. Into how many blocks it is divided? Yes. Number of blocks. (192 by 64). 3 blocks. B1, B2 and B3. B1, B2 and B3. How these 3 blocks are stored across these 3 slaves? This is master, slaves. S1, S2, S3. B1 is stored here, B2 stored here, B3 stored here. F1.txt divided into 3 blocks, B1, B2, and B3. B1 stored by S1, B2 by S2, B3 by S3. B1, B2, B3 stored in S1, S2, and S3. B1 by S1, B2 by S2, and B3 by S3. Now, that is how the data is stored, right? How this data. Think that totally 3 blocks, 192 MB, some 30 lakh records. So assume the 10 lakh records in this, 10 lakh records in this, 10 lakh records in this, into 3. Data processing. Now, how this data processing, right? Yes. Your job is to process f1.txt. Job is divided into tasks. Number of tasks. Always in Hadoop, job is divided into tasks. Number of tasks always depends on number of tasks in Hadoop always depends on number of unique blocks. Number of tasks always depends on number of unique blocks. How many blocks here? 3 blocks. 3 blocks means how many tasks? 3 tasks. 3 tasks. T1, T2, and T3. Job is to process f1.txt into how many blocks? B1, B2, B3. Okay, B1. Okay. Job is divided into T1, T2, and T3 tasks. How this T1, T2, the job is divided into 3 tasks. T1 task is for executing what? B1 10 lakh records. T2 task is for executing B2 10 lakh records. T3 task is for executing B3 10 lakh records. T2 is for executing B2 10 lakh. T3 is for executing B3 10 lakh. Who should execute this T1 task? Who should execute this T1 task? Who should execute this T1 means? Try to answer everyone. Who should execute this T1 task? Is T1 is S1 only can execute, right? Means T1 task is for executing B1. B1 present in slave 1. So S1 only can execute this B1 10 lakh records. Okay. And who should execute this T2 task? B2 10 lakh records? Slave 2 only. There is no other chance. Because B2 block is present in S2. S2 only can execute that. Who should execute this T3? T3 is for executing B3. S3 only, slave 3 only can execute. So all the 3 tasks T1, T2, T3 are executed by 3 slaves. All the 3 tasks are executed by 3 slaves. S1, S2, and S3 parallelly. All the 3 tasks T1, T2, T3 are executed by 3 slaves, S1, S2, and S3 parallelly. All the 3 tasks are executed by 3 slaves parallelly. So full parallelism, high speed, full parallelism, high speed means here no task is in the waiting state. All the tasks are executed. So number of blocks equal to number of slaves means high speed you are going to see. High speed, full parallelism, no task is not in the waiting state. Observe this case 2, right? Case 2, observe this case 2, right? Number of blocks greater than number of slaves. Four blocks, 2 slaves. B1, four blocks, 2 slaves, S1, S2. F1.txt, think that you got 230 MB size. Size is 230 MB. Default block size 64 MB. Assume default block size equal to 64 MB. Into how many blocks, how many 64 MB blocks, right? Into how many 64 MB blocks it is divided means yes. Number of blocks. Two 30 by 64. 4 blocks. B1, B2, B3, B4. See this is the master node, master and slaves. In Hadoop, data is stored in the form of files, the file size to the TMB. So by default, each file is divided into smaller parts. Each part we call it like a block. Into how many blocks it is divided means 230 by 64, 4 blocks, B1, B2, B3. How many slaves here? Number of here, assume that you got only 2 slaves. How these 4 blocks are stored across 2 slaves? B1 block here, B2 block here, B3 here, B4 here. B1, B2, B3, B4. F1.txt. F1.txt is divided into S. Into how many blocks? B1, B2, B3, B4. Where B1 is stored? In S1. B2 in S2. B3 in S1. B4 in S2. If the number of blocks are more and number of slaves are less speed. Now observe how this data processing is going to happen. Job is to dividing the job into tasks. Into how many tasks? Okay, job is to divide into tasks. Into how many tasks means number of unique blocks. I am saying the word unique here. Later I'll say why I'm saying the word unique here. So here how many blocks? 4 blocks. 4 blocks means how many tasks? T1, T2, T3 and T4. T1, T2, T3, T4. How many, right? 4. Okay. Job is to process f1.txt. Divided into how many tasks? T1, T2, T3, T4. Assume T4, T1. Who should execute T1? Yes. T1 is for executing B1. Who should execute T1? S1 or S2?
S1,
S1, right? T2 by
S2,
S2. T3 by
S1,
T4 by
S2.
S2. So here S1 is there, S2 is there. S1 is executing T1 and T3. S2 is executing. When T1 is executing, When T1 is executing, T3 will be in the waiting state in S1. If I go to S2, right? If T2 is executing, T1 executing, T3 will be waiting. T2 executing, T4 will be. Means only two tasks are executing parallelly. T3 and T4 will be in the waiting state. T3 and T4 will be in the waiting state. Okay. So first after T1, T2 execution finished, next T3 and T4 are executed. Okay. Means here lesser speed, right? Here lesser speed. Why less speed? Some tasks are in the waiting state. First the tasks are complete, then only this. Okay. Next observe example 3, case 3. Case 3. If you observe this case 3, right? More box, only one slave. More blocks, only one slave. Assume that you got 4 blocks. B1, B2, B3, B4. Only one slave, S1. Only one slave, S1. So here, all this, okay, this is your master, this is your slave. All this B1 stored here, B2 stored here, B3 stored here, B4 stored here. This S1, this master, or name node we say, which stores metadata information. F1.txt divided into 4 blocks. B1, B2, B3, B4. B1 stored by S. S1, B2 stored by S2, B3. Sorry, S1 only. B3 also by S1, B4 also by S1. All these blocks are stored in S1 only. Okay. Now, job to process F1.txt. How many blocks? Number of tasks, number of unique blocks. How many unique blocks? How many unique blocks means 4. Job to process F1.txt. That is T1. Okay, 1 second. T1, T2, T3, T4. For executing B1, T2 for executing B2, T3 for executing B3, T4 for executing B4. Who should execute T1 S1 only, T2 S1 only, T1 T3 S1 only, T4 S1. All these four tasks, all these four slaves, all these four tasks are executed by a single slave sequentially. T1 next T2, T3, T4. Yes, all these four tasks are executed by the same slave sequentially. So if you observe this, in case 1, four tasks, four slaves, nothing is in the waiting state. In case 2, four tasks, two slaves, two tasks will be in the waiting state. Case 3, four tasks, means 3 tasks will be in the waiting state. Only 1 task will be executed. Okay, now if I come back to this case 1, if I come back to this case 1, right? 3 blocks B1, B2, B3 executed by the 3 slaves S1, S2, and S3. 3 blocks B1, B2, B3 executed by the 3 slaves S1, S2, and S3. Suddenly, if anyone's system goes down, okay. If suddenly any one slave goes down, 2 things you can observe here. Here T1 task, T2 task, T3 task. 3 tasks assigned to the 3 slaves, right? If this particular slave is down, 10 lakh records are lost. Second is this T2 task is failed. Okay. How come Hadoop is going to overcome this kind of situation? Means we have got replication and fault tolerance, right? Replication and fault tolerance in Hadoop, right? Yes. Replication and fault tolerance in Hadoop. So Hadoop, how this replication and fault understood, right? How this data storage is happening. If any file divided into blocks, those blocks, everything happens in automated fashion. We no need to perform anything. But only thing is business logic while processing. Okay, the T1, T2, T3 tasks, how they'll be processed, and what is the business logic we are going to forward, that we will be specifying. Okay, fine. Understood all these 3 cases, everyone? Any queries in this? If more slaves, more speed. If less slaves, less speed. If only one slave, no parallel processing at all, right? Yes. How the data is stored? Yes. Now coming back here, right? Yes. Configuring default block size is default block size 64,128. We can also set our own block size. Configuring our own block size. Configuring our own block size. So for that, go to Hadoop installed folder. Go to Hadoop installed folder. Hadoop, etc. Within the conf folder, hdfs-site.xml. We'll see an XML file. Open this XML file. And configure the following. Open this XML file and configure the following. So in this XML file, right, we need to have configuration, our own tags. Opening tag, closing tag. Every XML tag will have this, right? Opening and closing. And within this one property. Property configuration property. DFS dot blocks dot size. What is the default block size? 64,128. Even I can set into 60 MB or 50 MB. Default block size. It will be divided into 50 MB blocks. /value. If you're not specifying any file, right? By default, it takes 128 MB. But you can also configure your own block size. So this is how to configure the block size. Next is replication and fault tolerance. Replication and fault tolerance mechanism. Okay. So any queries you got as part of today's session or anything related to this, right? Big data batch. Okay. Fine. So tomorrow also you can join the session, right? So you can join the session, right? Tomorrow you can join the session at, okay. Same link you can follow tomorrow. For tomorrow's class, you can follow the same link. But the timing, join at 5 o'clock, 5 p.m., right? Yes, 5 o'clock you can join. Fine. Any queries? Can just go to the course content. We'll see in brief, in depth, we'll be discussing, right, with multiple working examples. Fine. So I'll stop for today. We'll continue tomorrow, right? Yes. You can see in the chart for the payment process, course content and for the payment process. And don't forget to share the screenshot of your payment to DurgaSoft online training. Okay, to share that payment link, right? Yes. Tomorrow also you can attend the same. Okay, using the same link at 5 p.m. to see more on this, right? Fault tolerance and replication. Okay, fine. I'm stopping for now. We'll continue.